I'll just ask a small question. So could you please tell me why we are here today? Why we are meeting up in the morning to learn the big data or to learn the Hadoop, right? So what is Hadoop? Hadoop. Hadoop is an open source framework, which is a Java framework, which is designed and developed by Doug Cutting. Okay, it's a Java based framework, which is meant for the store huge amount of the data, process huge amount of the data. Correct, right? But why this framework came into picture? It is some solution for the some problem, right? It is a solution. Hello.
Yeah, Ravi, some sounds, Ravi. Your voice is not clear.
No, not.
Please mute your audio.
Not from my side. Yeah, not from my side. And it seems that it's from you guys' side. Now it's good, right? Yeah. Fine. So this Hadoop is a solution for some problem. So we'll see what is the problem, who is causing the problem, how we will solve the problem. Right? If you guys have gone through my demo classes, you could have answered these things. Anyway, fine. We'll start from the basics and we'll see the work from the very first. Okay. So first we are going to see problem, cause of the problem, and we'll see the solution. And what it will do? It will give them whole picture, what is the problem, who is causing the problem, then how we will solve the problem. So we will be seeing that. So you guys already have an idea how our traditional approach is working. So our traditional approach is working in such a way that we will be having some sources from where the data is getting emitted, right? Some source will be there where from data is getting emitted. This is a raw data. These sources can be your financial institutes, your ERP applications, your social media, or your sensors, your satellite, and so on. It can be anywhere. Source is nothing but who is emitting the data, who exactly emitting the data, who exactly giving the data, who exactly producing the data. That's called source. The source can be your financial institutes or your ERP applications or your social media or a satellite or sensor. Whoever is actually generating the data. The raw data. Right? Why we are calling the raw data? Actually, this is the data which is generated by these guys, which contains so many fields, right? So much of information. Let's take a simple example. The log. The log will contain so much of information which is required and which is not required. Along with the both will be there in the log, right? It contains the IP address, it contains the date, timestamp, the type of the log, and it contains which class it is, which method it is, which line of the class it is, and then what is the process, whatever we print over there, right? So we may not require all the details. To process and to produce a valuable produce a report, right? We may not require all the information because it's a raw data which contains everything. But we may not interested on all the fields. We may interested on the specific fields like what is the IP address, what is the browser, what type of log it is, and what is the OS he has used, and what is the user ID, right? We may interest on only these fields. Then how we will get these fields? We will get these fields by using ERT tools, ETL tools. We will get these fields by using ETL tools. What is the ETL? What is a ETL? ETL is a extract, transfer, and load. Extract, transfer, and load. How we will get the valuable information out of the raw data? We will use ETL tools. These extract, transfer, load. What it will do? What is the purpose of the ETL? The ETLs are tools like Informatica, Oracle, OBA. There's some ETL tools, right? Talent, right? These are the ETL tools. What they will do, they will extract from the raw data, they will transfer them and load into a database. Before loading into database, what they will do, they will normalize. They will normalize the data. What is the normalization? Harsha or Anil? What is the normalization?
Normalization in the sense we are keeping the data in the proper format.
Okay. Normalization is a process of removing the duplicates, right? Removing the redundancy, right? There are multiple forms, like first normal form, second normal form, third normal form. There are some normalization forms they will apply, and they will transfer and load into the database, into a DB, right? Now, on top of this data, this is the data which we have after processing ETL, after processing it, which is the raw data came. I have processed this raw data. After the processing the raw data, I got the actual data. What are the fields I interested? I got the actual data. On top of this, we may run in Java applications. We may run in .NET applications. We may run in .NET applications. We may run in some other applications, right? But to generate the reports, to generate the reports, we will be having a client machine. We will be querying from here. Then we generate the reports. Who will use this? Data science or business analyst or your data warehouse admin people. Or data warehouse means who is improving your business. This is how our traditional approach is working. Or you guys agree with me? This is how our traditional approach is working. Harsha and in the real time when existing, this is how it's working, right? Why we are calling it a traditional approach? Why we are calling it a traditional approach? Because our ancestors from some decades they started using the same process. Our ancestors means whom? Or like our seniors, already existing system it is. It is already existing system. Some people already used it. They felt it's a very good approach and they implemented from some decades. We are processing the same kind of data. Same kind of architecture. We're following the same kind of architecture. Then if it is when it is well fit, when our ancestors have used very well about this, used this product or this architecture, when they fitted into last year or before years, last 5 years before, then why it is giving a problem now? Okay, we'll try to see. This approach is well fit when you have a data and less amount of the data. When you have a less amount of the data. Let's assume that our data is grown. Let's assume that our data is grown. When your data is grown, Do we need invest on the ETL tools? Do we need invest on the ETL tools? Because we need a better ETL tool. It's a licensed one. It's not open source, right? It's a licensed. I need to invest. I need to buy a better tool. I need to get more license for this. But my data increase, and I need a better databases where I need to replace an existing system, where I need to replace this RDBMS. Here also cost is involved. Here also cost is involved, and when I process the data, let's assume that it has some 1 TB data. Let's assume that it has 1 TB data. Now, I want to generate a report. Let's take an example, Amazon. Okay, Amazon. In Amazon, I want to see what is the sales improvement, or I want to do analysis on last 1 year data. Last 1 year data. So, right now, this is what I'm trying to explain here. I have a log file. A transaction details file of Amazon. I want to find what is the sales last year. I want to find how many, what is the category of sales is more, which category of sales is more, like is a mobile has been sold out more, or home appliance. Then I want to identify mobiles, home appliance, books, like that. How many new customers are there? What is the revenue last year? Right? These details I want to find out. These are the analysis I want to do. Let's assume that now after processing this data become 1 TB. Or after processing the data is become 1 TB. Or let's assume that you just take 100 GB. Or you just take 100 GB. Now when I query from here, like select the statement. When I query from here, can you guys tell me where the process will happen? When I query the data, this is data center. This is data center where the data is there. Now I'm querying from my client machine. So where the process will happen? Where the process will happen? Sorry? Server means where? It's a data center or it's a client machine? Client server.
No, data center.
The process will happen data center? The traditional approach. No. The process will happen at the client. Client means this guy. You might have seen, I think already you guys are doing some e-commerce kind of application, right?
See, Ravi, in traditional approach, in that Tomcat server, if you select any request, it will contact given Tomcat name. It will return that request.
See, the Tomcat server, what you're talking about is Java application.
Okay.
And I'm talking about the generating reports. Reports will have their own tools which will directly talk to the database. The Tomcat server or some other servers are running, it's a web application servers, right? Those are web servers
Okay.
or web application servers. Those will run the applications. Even though your Tomcat server, how much data you are querying from your Tomcat server? Are you querying 10 GB, 20 GB? No.
Not that.
From the Tomcat server of WebLogic or WebSphere, you will be querying some MBs only. How will your Tomcat server be capable enough to handle this 10 GB? It will not be capable enough to handle this much amount of the data. What it will do, that also will run on your client machine, right? Java application is nothing but a client machine. Here, what it will do? In this case also, let me try to explain. In this case also, what it will do? It will just, you need a 100 MB. Let's assume that you need a 100 MB. The 100 MB of data you are querying to display on the front page. Okay, your Tomcat server will issue the query. It's like Java application. Ideally, you will be having a JDBD. The drivers will be there, where you will use that, and you will be having the connection. So many blah blah things will be there, right? When you issue the query, this 100 MB, where it will get processed? It will get processed at the data center. It will not get processed at the data center. It will get processed at the client machine. From wherever, yes, your Tomcat server, where your Tomcat is executing, where your Tomcat is running. Okay. And you tell me your voice is not clear. Yeah, tell me, Ali. I am there.
When you are using query with database, the database is going to query query and fetching the data from the database level.
Correct.
But the whole thing is depends upon database level, right?
No, your voice is not clear. And what I understand, when we query the data, the data we will be fetching the data from the database. Till there I have understood.
Yeah. Database has to do the things, all the things, right?
See, what you guys are talking about is small applications, small web applications, right?
Yeah.
So when you take the big web applications like Amazon.in or eBay or Flipkart kind of things, they will not run. They will not run. They will not. How can I say? I think they may using some better tools like the servers, like your instead of your Tomcat, they may using WebSphere, the better tools. But even though the process, when they query that, the data will get downloaded to your client. The client machine only, that your database server will be different, your application server will be different, your reporting server will be different, right? So your application server will download the data from the database. Your application server or your reporting server, they will download the data and they will process it.
So this is not there is no need to interact with the database. They directly interact with the client application.
Your voice is not clear. Could you please type again?
Yeah, I agree. In this scenario, we don't need to interact with the database only.
Sorry, Anil. Your voice is echoing. Actually, it's not that much clear. Arshad, do you understand what Anil is trying to say? Could you please tell me?
Ravi,
Yeah.
what I am asking now, one day it is going to download all the data from database to the client server.
Correct. Correct. Your SQL server or client server. Correct.
Yeah, no need to again and again, no need to interact with the database server. You are saying.
Okay. No, what I'm trying to say, when I want to query this Amazon data, let's assume that is a 10 GB data I have to process.
Okay.
When I issue the select query,
Okay.
from out of 100 GB, I want to process 10 GB because of the wear condition or something. Okay.
Okay.
What it will do, my machine will start download the data. My client will start download the data towards my client. Okay. process will happen in this client machine, the RAM. The process will happen in the RAM. If you take your mobile application, or if you take your mobile, if you take your laptop, where the process will happen? The process will happen in the RAM. The data will be temporarily stored in your RAM. Let's take your mobile. You have opened an application. You start running an application. Where it will run? It will run in the RAM. The same way here, when you issue a select query from the client machine, you start download the data towards your client machine. Then in the client machine RAM, it will start process the 10 GB data. It will happen in the client machine RAM. It means that your client machine should be that much capable enough to handle this much amount of data. Client machine is nothing but your server, your SQL server, whatever it is, to who connect to the your database. Okay, this machine has to be that much capable enough to. This machine has to have that much processor, and the time is more important. Let's say I want the report. When I say I want the report last 1 year, how many new customers have joined, how many mobiles has been sold out, how many house appliances has been sold out, how many books has been sold out, how many some other applications has been, some other items has been sold out. You say, give me off day, I'll generate the report. If you say this thing to client, will the client with us? No. He will client say that, boss, not off day. I want the report in 10 seconds. I want the report in 10 seconds. If you are capable enough, if you are able to give me a report in 10 seconds, give. Else, I have some other vendor where I can go on and get it. Right? So, what is the problem here? When you issue a select query, start download the data from the server to client machine, which is a 10 GB data. To download this 10 GB data, will it take 10 to 15 minutes? Will it take 10 to 15 minutes? Then you should have good hardware for the client machine which can handle this 10 GB data. Fine, you can say that I have a good hardware also. I have the good hardware also. The first problem what we have seen is cost. The second problem what we are seeing is time, because it has to download client machine and it has to process. Fine, I have a very good bandwidth where I can download 5 GB per second or 1 GB per second. My bandwidth is 1 Gbps. My bandwidth is 1 Gbps. Okay, fine. Okay, very good. You go ahead and download it. Okay, it means that okay, I can download in 10 minutes only. I can process it. Fine. But while processing this 10 GB data, is it a sequential process or is it a parallel process? Is it a sequential process or a parallel process? Guys, I'm asking you guys only. Is it a sequential process or parallel process? Harsha? Anil?
Yeah, it's sequential, right?
Yes. So only single machine where the whole data come into single machine, and it is a sequential process. And Anil, I think you are telling it's a parallel, right?
Ravi, 1 minute. Here you are talking client machine, right? Client machine means, see, our browser there in our laptop, right? You are requesting something to so-and-so accepted.
No, still you are talking about application only, Harsha. I'm talking about where I'm generating the reports.
Okay, directly without any middleware, any complex server, you are directly using the database and getting that data.
Correct. I have some tools where I can generate the reports. MSBI,
Okay.
business
Uh-huh.
intelligence tools, or some other reporting, Tableau reporting tool, or JSPA reporting tool. These reporting tools never use any Java application. They will directly they will directly run on the server. I mean
Okay.
database.
Got it. Got it.
Okay. So it's a sequential, right? Anil, you're telling that it's a parallel. I mean, do you have any confusion here? It is not a parallel. Why? Because it is a single machine. It's a single machine, and it has a single processor where the process has to go through a single machine. It because the whole data is there in single machine. The process will go in single machine. Maybe it may have a multiple threads or different core. Maybe it has a different cores, 4 cores. But your select query 4 cores, 8 cores, 16 cores, different cores may be there. But whole data is going to process by single machine, right?
Yeah.
It's a sequential process. One after one only it can process. Why? Because the whole 10 GB data is there in the single place, and the data is you didn't split it. The whole data is a single data, so whole data has to be processed with a single processor. Here not even
This
processed with a multiple processors, right? Because even though if you have a 4 core, how the 4 core data will be? How your processor knows that this how your processor knows that this part should handle by processor 1, this part has to be processed by processor 2, this part has to be processed by processor 3. How it will know? Because your 10 GB data, let me put in this way, your 10 GB data, is stored in single place in the RAM, right? This is your 10 GB data. Your 10 GB data is stored in this RAM. Now, even though your machine is 8 core, 8 processes can run at a time. How your CPU will know that this part 2 has to be processed by me and this part 2 has to be processed by me? How it will know? It will not know, because you have used a select query. The select query will go and execute on top of this data. How it will know that part of the data go by process 1, I mean core 1, part of the data go by part 2 or processor 2, part of the data for process 3, and the part of the data processor 2. Do we divide the data? No, it's a single data. It's a whole data came into the single machine. So we didn't divide the data. But you may say that in RDBMS we have partitions. The partitions is completely different. Okay? Here the process is a single processor. It's a sequential processor. So no parallel process. No parallel process. If you don't have the parallel process, time taking. Obviously, it will take more time. It's more fast. No parallel process. Is the data is a single machine or multiple machines? Single machine. So no distribution. Data is not distributed. Let's assume that even though, okay boss, I have a good amount of money with me because I love this architecture. This architecture is there from decades of years. I don't want to change my architecture. I'll go with the same architecture. Let it be cost me. I'll invest more on it. He said that I have more money. I can invest here. I can invest here. I can invest here. He said that he's ready to invest more amount. Let's assume that the whole data will go into one database center. This is failed. Do we have a backup? Even though we have kept the backup in one other machine, we have stored in one other machine. Is it automatically comes alive? Let's assume that I'm processing the data on this data center. I issued my select query. While processing it, your client machine or your database is down. My job will success or fail. I started querying some data from the data center. My server is failed. Now, my job will fail or success.
No, sir, it will go for backup server, right?
Automatically will it go backup server?
Yeah.
No. In traditional approach, there is no that facility. Who will tell to go backup machine? Are we telling somewhere? Are we specifying anywhere? How how it will go automatically to the backup server? It will not go. The job will fail. The job will fail. Then after some time the administrator may bring the backup machine and he will give the connections and he will give some IP addresses and all those configurations he will do. Then we need to give specific again a select query. right? There is no automatic failure. There is no auto fault tolerant. It's called auto fault tolerant. And no auto scaling. Not auto scaling, it's called scaling is difficult here. Scaling is difficult here. Scaling is bit difficult here. Scaling up. What is the scaling? What Ravi, what you are telling about what is scaling? Scaling is today I have set it up for my data is to handle 1 TB data at a time. I have designed my architecture to handle 1 TB data. All of a sudden I got 1 peta of data, 1 PB. Is the scaling up is easy here? 1 petabytes of data is coming. I have set it up for the 1 TB, but I am getting 1 petabytes of data. Is my hardware automatically, is it easy to change my hardware on the fly?
No,
Is,
sir, not easy.
right? Here, the scaling up is not easy. It's not easy. There is no auto failure, there is no duplication, automatic fault tolerant. It's not distributed, it's not parallel and time consuming and cost, and also it's not automatically scaling up. Right? So these are the limitations. These are the limitations with your traditional approach. Now I'll ask one question. This traditional approach was working very well. It's too good. Why now it is giving a problem? Who is causing the problem? Who is causing the problem here?
Data, right?
Exactly. Data. The data has become huge. Olden days, the less data was coming, this architecture was easily handled. It was easily handling this data. This data before it was this architecture was working very well because of data was less. This architecture was capable enough to handle that. Now data is grown. Now the data is grown. It is not able to handle it. That's why we are facing these limitations. There is one more limitation. Now what we are doing here, when I query the data, I started downloading data from here, right? I started downloading data from here, which is taking 10 minutes or 15 minutes, right? Instead of downloading the data, my logic is you have written your Java code to process some data. How you have written 500 lines of code. What is the size of the 500 lines of code? Asha?
It's a KB, right?
Sorry?
500 lines of Java code, it's KB, right?
Yeah, you have written 500 lines of code. What will be the size of the Java code? Some KB or 1 MB?
Okay.
Which you have written a Java code, 500 lines or 1000 lines of Java code, okay, to process something, some business logic you have written. Ideally, to process your data. Or else, let's say, you have written a select for PLSQL code to process your data. Okay? How much the data will be? 1000 lines. Let's assume that you have 1000 lines. It will be 1 MB. Size of the file or 10 MB max. Size of your logic 10 MB. Instead of downloading data from data center, I will upload my logic towards my data. Wherever my data is there, I'll upload my logic towards my data and I'll ask them to process in the data center. I'll ask them to process here. Which is better? Downloading 10 GB or uploading 10 MB? Okay, let me put it this way. My server is there in Singapore and I'm connecting from the India. Even though we are both on the same network, in the traditional approach, in the same network, same client network only we are, where the speed is too good, So I have issued a query. Or else I have executed my set of SQL queries, which is there in the .sql file. I have executed, which has the 500 SQL files plus SQL queries. Okay, and when I execute that, it will start downloading the data from the data center from Singapore. My data center is in Singapore. I'm executing from here, which is easy. It will start download the data. But what I am saying, you 500 lines of code, you send to the Singapore. Don't download from the there. You send your 500 lines of code to the Singapore, execute there only, and get the results. Which is easy. Sending to Singapore is easy. Getting from Singapore is easy.
Sending from Singapore.
Correct. Why? Because if I want to get the data from the Singapore, I have to get the 10 GB data. But if I want to send to the Singapore, it will hardly 10 MB. Right. So that's sending to Singapore, not from the sending to Singapore. That is called data localization. That is called data locality. In traditional approach, we do not have no data locality. Data locality means wherever the data is there, you go and process there. That is called data locality. What is data locality? Wherever the data is there, you go and process. But in traditional approach, the process will happen at the client. You will start download the data, then it happens. So in traditional approach, we do not have the data locality. Are you guys clear about these limitations?
Yes, sir.
Any doubts here? Any doubts still here? Is this clear? Is this given on some idea how it is working and
Yes. Yeah.
it's clear, right? Good. Nice to hear that.
Yeah.
Now, who is causing the problem here?
Data.
Big data. The huge amount of the data, right? So let's see. The problem is caused by big data. What is big data? What is a big data?
Huge amount of data.
The huge amount of the data. Huge amount of data. Right. How much huge? How much huge?
Like TB.
Is there any limit?
No, sir.
No.
So can I say 100 MB is a big data?
No.
Why?
This is a less amount of data.
How you are saying that it's less amount of data? With respect to what you are telling it's a small amount of data?
Like bytes.
Not
You're
bytes.
measuring bytes.
No, correct only. It's a megabytes only, I understand. And even 1 TB data also when you convert into megabytes, that's also in megabytes, right? I understand that.
Yeah.
How, how,
Yeah.
can, how can you say that it's a small amount of data? With respect to what you are telling it's a small amount of data?
A
Why?
volume.
Not exactly. You can able to process this 100 MB data using traditional approach. That's what you're trying to say. You can easily process it. My system, my architecture will work very well, right? I can store this data anywhere, I can process this data anywhere because it's a small amount of data where my tools are capable enough to handle this. That's what you're trying to say, right? Because of that, you're telling it's a small amount of data. Let me say I have taken email application. Okay. Can I send this 100 MB through email?
No.
So with respect to email, it is a big data. With respect to email,
Yes.
it is a big data.
Yes. Yes.
So what does it mean? It means that when we say it's big data, which is not able to store, process and efficiently by using that specific application or with what context we are talking. It ideally means that when I say big data, it's a huge amount of data. If anyone asks how much huge it is, which my current system is not able to handle, whether it can be your email application, whether it can be a Bluetooth application, whether it can be your RDBMS, whether it can be your anything. So my current system is not able to handle that data. I am saying that this is big data. Understand, right? What I'm trying to explain here?
Yeah.
Now, we have seen what is the big data and we have seen what is what are the problems we have seen and who is causing the problems are, and we'll go ahead and see what is the classifications of the big data. It's not ideal big data, it is a data. The classification of the data. Classification of data. The data has been classified into three different categories. What are they? Structure, unstructured, semi-structured.
Okay.
Yeah. Yes, we have seen the problem, and now we are knowing more about who is causing the problem. This guy is a big data, right? We have seen the problem. Now we didn't get into the solution. Now we are going to know about who is causing the problem, So we understand that big data is causing the problem. Now we are knowing, we are getting in details of the guy who is causing the problem. We are going to know about in and outs of this problem. Okay. It's not a problem statement. It is who is causing the problem. We are going to know about him. Here in our case, big data is causing the problem. We are trying to know about more details about your big data. Okay. Now, what is the structured data? I think you guys are aware of it. So we'll just quickly finish this.
Database, relational database.
Structured data. Structured data means when I look at the whole data, it has been followed a specific pattern or it has been followed a specific schema. Then I can say that data is a structured data. How? When I look at the whole data, my data is properly followed a schema which is a column schema. It's followed a column schema. My whole data has been in the columns. And some number of rows, it depends on how much data you have. So my data is followed a specific schema which is that's called columns or that's called a pattern. Whole data will be divided into the columns. That's my pattern. So whenever I look at the data, the whole data, so it is following a specific pattern. So So that kind of data I can say structured data. What are they? Your database tables, views, right? Your examples are DB tables, right? XML files, sorry, XLS files, spreadsheets, XLS.
Yes. Yes.
Okay. Your CSV files, can I say your CSV files? CSV files, which are comma
Yes.
separated values. When you look at the whole data, it's whole data will be whole data is it will be how it looks. The whole data looks such a way that it has been separated by comma, right?
Yes.
That kind of data. If you see any data, the whole data has to be followed a single pattern, a single delimiter. I can say in the database tables, what is the delimiter? Columns. In Excel sheets, columns. In comma separated values, comma is a delimiter. It means that a single delimiter is there, right? That kind of data we can say
Yes.
is structured data. To process the structured data is very easy, we have a traditional approach to process the structured data. Okay. Now, unstructured data. What are the examples for unstructured data? What are the examples for unstructured data? Any idea?
No.
Unstructured data is like images,
Video.
audio, video. Do they follow any structure? Do they follow any structure? No, they will not follow any structure. It's ideally bits and bytes. So they will not be having any structure. Right? Are you guys agree with me?
Yeah. Yeah.
Yes.
Next.
Anyway,
Go ahead, Anil.
I'm going to do the images, videos as well as all these things are also with the one PF, with the P only, right?
Sorry. Audio, video,
So if
images
you
are
want to,
also.
if you want to store these images, videos, and audios into database, we are going to go with one key, right?
We'll go with one column.
Yeah, with the key, one key column.
Yes, correct. But how it will be
So it
structured?
will be,
It will not be a structure, right? See, when
uh,
you look at the whole image, does it have any structure? When you look at the video, does it have a structure? What you are trying to say, I understand. So, Ravi, I have some set of columns. Let's assume that I have three columns.
uh,
In the third column, I am storing image.
yes,
So, do you say it is a structure? Your image, I am talking about. I'm not talk, when I'm talking about the whole data. This data may contain something else here, ID, some name, ID, name, and image. So this may be employee data. This
yeah,
employee data has a structure. I agree. I totally agree with you.
yeah,
But when I talk about only employee image data,
uh-huh,
employee image data. So some employee image data. I'll just draw a small thing here. This is just employee image data. Does this follows any structure? You may storing this here. I understand. But does this have a, when I look at this is a whole data for me. This is not whole data now. This is my whole data. When I'm looking at one image, is it a structured data?
No.
Let,
Okay.
let's assume that some robbery has happened. Your CC camera has been captured some video, right? And some of the places it has been captured some images, and some of the places it has been captured some of the audio. So, is that image is a structured data? Is that video is a structured data? No, right? So
yes, image you are saying, defining, no?
yeah, so if you are storing your image into one place in a column, Yes, that data is a structured data, but image is not a structured data.
Okay.
In this case, your employee data is a structured data, but your employee image is not a structured data.
Okay.
Now, let's talk about a semi-structured data. Let's talk about semi-structured data. Any idea guys about the semi-structured data?
XML files.
Any idea about the semi-structured data?
XML files.
Sorry?
XML files.
Uh, XML files. Yeah. Okay. Your text file. Your text file also semi-structured data. Your text files also
Yeah.
semi-structured data.
Yeah.
Your Word documents.
Yes.
So how can you say the text file is a semi-structured data, Anil?
Yeah, in the XML files also we are able to give information to one
No, no,
employee.
no. Forget about
Employee,
XML file. I'm asking about text file. TXT.
in the text file also we are going to convey some information about some
I
like
mean,
if you take an employee.
yeah, any kind of anything is conveying something that I understand. Anything is conveying
Yeah.
some type of data, some information.
Mm.
But how can
Mm.
you say a text file or a Word document is a structured data or semi-structured data or unstructured data? How can I prove that?
How
Mhm.
will you prove anything?
Sorry. Okay. Let me put in this way. When you look at the structured data, when you look at the text file, okay, .txt file. So are able to find anything. See, when you're specifying it is a structured data or semi-structured or structured data, you have to take the consideration of the whole data, not the part of the data. You should take the whole data as a consideration. You are going to write a logic for the whole data, not the part of the data, right? Your logic, your business logic is going to work on the whole data, right? Let's assume that I have taken my text data. I'll say here heading, then underline. Hi, how are you? XYZ. Then again one more heading, something, one more heading, something, and subheading here. Points, bullet points, here bullet points. Right? Do you say it's a structured data?
No.
Or it's following the same structure? I may have a
No.
heading, I may not have a heading, I may have something, right? But when I look at the whole data, there is no structure. But when I look at the part of the data, like when I look at the lines, when I look at the line is like how are you? How is your preparation? Something, right? When I look at the part of the data lines, but I'm seeing that the words has been delimited by single space. It's delimited by single space, right? Am I correct, guys?
Yeah.
Yeah.
When I look at the part, when I look at the whole data, I don't have any structure. But when I look at the part of the data, I see some structure is there. Some structure is there. So that's why I'm saying the text files are semi-structured because part of the data has a structure but the whole data doesn't have a structure. When I look at the whole way, I cannot say it is structure. But when I look at the part of the data, it is have some structure. That is why we call text file as a semi-structure. Clear guys? Your Word document.
Yeah.
Your Word document. Your text file. The Word document is nothing but a text file only. So the same. And your emails. When I look at the email also I'll not be finding any structure. I'll be seeing a two subject, a signature, some XYZ will be there. But The software will be having a heading, subheading, some bullet points, something will be there. So I can say my emails also semi-structured data, right? My emails also semi-structured data. As I said, XML file also semi-structured data, right? Are you guys clear why XML file is semi-structured?
Yeah,
Yeah, yeah.
My log files. Log file also semi-structured. Why log file is a semi-structured? When the log is generated, it will have an IP address, it will have a date, it will have a timestamp, it will have a browser, it has a class, type of log it is, some XYZ will be there. So it has a proper structure, no? It is delimited by the space. Whole data, when I look at the whole log file, I have a structure. How can I say it is just semi-structured data? How can you say it is a semi-structured data? Anil and Harsha? So when I look at my log file, IP address is there, space, date is there, space, timestamp is there, space, type of log it is there, space, the software, I mean what is the browser I have used, everything is divided with the space. The whole data has a spaces. So how can I say it is this log? How can I say it is a semi-structure? So I can say it is structured, no? The log
Yeah,
file,
exactly.
I can say structure, right? How can I say it is a semi-structure? It has a properly structured. When you look at this whole data properly structured with the space, then how can I say it is a semi-structured, guys? How can we say it is a semi-structured?
Mm.
Okay,
Is there any formatting issue? Or last file barabar lagta?
no. If log is this is the log file which is successful log, means the whole flow successfully followed. But
okay.
what?
Now it's fine.
Yes, what happened? Some exceptions occurred. What happened?
That will be removed. Yeah, that will be removed. The successful folder.
Right. Some error occurred. Some problem happened with the class. Null point exception came. Or your
Yeah.
out of array index out of boundary exception came, or runtime exceptions, or whatever the exceptions are came. So does that follow any structure? It will just start
No.
printing a whole stack of your exception, right?
Yeah.
So can I say my log file is not a structured data?
Yes.
So can I say my log
Yes.
file is a semi structure?
Yes.
Yeah.
Very good. So your log file is a semi structure, and JSON data. JSON data. One second, guys. Uh, Srinivas, no class for you, Srinivas, today.
Oh, no class, sir. Are we?
Yeah, I have messaged you in the WhatsApp.
Okay,
Okay,
okay.
okay, okay. If I
Actually,
understand. You have given the new, you have given me a new number, right? Yeah, yeah, I did add in the group. Uh,
oh,
Others are, I mean, I have informed others. Fine, fine. Yeah. I'll add you in that group, Srinivas.
okay, sir. Okay, thank you.
So, how is your new work, Srinivas? How is your new place?
Yes, sir. Yeah, it's going on.
Okay.
Actually, first of all, one issue came, that is,
Mm-hmm.
actually sequence file how to load into Hive table and how to do analysis.
It's very simple, Srinivas. You ping me,
Yeah,
okay?
yeah, yeah, yeah.
When you face any problem, right? When, you take the
Yeah.
screenshot and ping me in WhatsApp. I'll help
Yes,
you with
sir.
that. Okay, it's kind of support.
Mm.
I'll give some initial support for you.
Yeah, yeah. Thank you.
Yeah, bye.
Oh.
You can talk at.
Today, what is this class, Ravi? What is this
No,
class?
this is completely different, Srinivas. So I will see in the. I'll explain you later.
Okay.
Okay. Okay.
So he is from which company, sir?
So
Big data Hadoop only?
yes, yes, he is from Big Data Group only. He is 630 batch.
Okay.
So he got
Because
placed into. Sorry.
he got opportunity in Hadoop only?
Yes, yes, he got placed in Hadoop.
Okay.
It's, I mean, he still completed his course, but he completed only MapReduce. MapReduce completed HDFS and Java. He gone through all these three concepts, and he cracked the interview. Now he is placed.
Ravi,
Yeah, tell me, Harsin, Anil.
can I able to train you for the purposes of experience?
Sorry,
Can I, if it is training, can I go with the 2 plus years of experience with Hadoop?
4 plus years, right?
Yeah, right now I have 4 plus years of experience in Java and like that.
Easily you can go with Anil. What you can say? You can say 2 years of experience in Hadoop. Rest of thing in Java.
Yeah,
See,
yeah, yeah, yeah.
The Java with the Hadoop combination is too good. Okay, why? Because
Okay,
the tool has been designed developed by using Java only. That is one point.
okay,
The other thing is the processing the data, like you say Hive, Pig, or what are the tools they say. Internally, it converts
okay,
to the Java code.
yeah,
So that is another point. And
okay,
the latest tools like your Scala, not Scala actually, Scala is another language. Your Spark is Java only, Java 8.
okay,
So Java guys can easily understand Hadoop. They can easily crack the interview. I'm also from Java
okay,
background.
okay.
Yeah. Okay, let's continue.
How much?
Sorry.
What? Okay, okay, carry on.
No, go ahead and tell me. I'll clarify your doubt and we'll continue.
No, 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 this time, how much years of experience in IT?
I have 8 years of experience, Anil.
Okay,
So I have passed out
okay,
in 2007.
okay, okay, Ravi.
Yeah, fine.
Thank you.
So this JSON data. So what is JSON data? Do you guys have any idea?
Yeah, Jason data is having like a key value page.
Exactly. It is a key value page. Key value. Then its proper structure is there, right? How can you say it is a semi-structure? Key is there, value is there. What are you telling? All unnecessary things. So key is there, value is there. How can you say it is a semi-structure?
The value again, key value is there, right? Same.
Yes. Your value can be again a key value. Your value can be an array of values, or your value can be a list of values, right? If we say, let's assume that if we say delimit by semicolon, with this value will come. Again, this also will get semicolon. So, which one will take? Whether you take this or you take this. How it will be considered as a structure? In the columns, in the comma separated, when I say comma separated, good, I'll always get the first word, second word, third word like that. Alright? But when I say delimit by semicolon, which one will you get? How will you delimit the data? We have to write our own procedure for it. We have to parse it. We have to parse it explicitly, right? By using Jackson parser or JSON parser, right? So that is the reason I'll say my JSON data is a semi-structured data. Clear, guys?
Yes.
Yeah, yeah.
Now let's see characteristics. We have seen only classification. Now let's see characteristics of data. What are they? They are 6 V's. First V is volume. Second V is velocity. Third V is variety. Fourth V is veracity. Fifth V is variability. Variability or variable. VLITY. Variability. The sixth V is value. These are the characteristics of data. See guys, no one will ask what is the structured data, what is unstructured data, what is semi-structured. They may ask what is the structures, what is the semi-structure like that, but no one will ask what is the 6 V's, what is the characteristics of data, what is the classification of the data. No one will ask them, but these are for our understanding, right? So the first V represents how much of data we are handling, how much of data we are going to process, how much amount of data I am going to handle in my cluster. That is the first V represents. Understand what is the volume?
Yeah, yeah.
Velocity. Whatever the data we are telling here, how much data is coming, it's 1 TB. Let's take an example of 1 TB. This 1 TB data, how fast it is generated. How fast it is generated. This 1 TB data, whatever you said 1 TB data, how fast it is get generated, how long it is taking to generate 1 TB data. And variety, what type of data it is, whether it's a structure, whether it's a semi-structure. Okay, you are going to handle 1 TB data. It is generating to generate 1 TB data. You taking 1 week time. But what type of data it is? Is it a structured data? Is it a semi-structured data? Is it a unstructured data? What type of data you are handling? Veracity, how accurate the data is, how good the data is, how good it is. Let's say sometimes we'll be saying that hashtags, hashtag India versus Pak, hashtag India versus Pak. So what does it mean, Anil? It is the war between these two guys? Is a match between these two guys, or is a business between two guys? I mean, two countries. We don't know. We don't know
Yes.
accuracy of it, right? So sometimes instead of saying happy, we'll just say symbol. We'll just say the symbol. What does it mean? Sometimes instead of asking party, we'll just send a symbol. We'll just symbol
Yes.
it's kind of a symbol. So what does it mean?
Yes.
How accurate this is? That is how good it is. How trustworthy it is. It is represented by a variety. And variable. Today, it's a kind of variable. So let's take we're defining variables in Java, right? Variable. So today, I'm handling structured data. Tomorrow it may be different data. Tomorrow it can be different format of the data. Today I'm using comma separated. Tomorrow it can be column separated. Day after tomorrow it can be JSON. So the data is varying, right? Variable. So keep changing, right?
Yeah, yeah.
It's also is kind of what type of data, but how frequently it's changing. How frequently it is changing. And value. So value is the most important V of a data. The Amazon is processing the data, or Flipkart is processing the data, or eBay is processing the data. What are getting benefit? What is the benefit they're getting? Because they're improving their business. Because of this data, they're improving their business, they're increasing their customers, they're launching a specific products. So that's the way they come into exclusive shopping. Exclusive. You say Amazon exclusive, Flipkart exclusive, you'll not get a product anywhere. Only you have to go with them only. You'll not get anywhere. That's how the exclusive business started. Let's assume that today 1,000 customers are there. The new product has been launched. 1,000 customers are visited the site, and out of 1,000, 400 are bought the product. They taken the product. 1 second, guys. Any disturbance? Are you guys able to hear me? Okay. So let's take your Amazon or Flipkart. So this Amazon, Flipkart, what happened? The 1,000 customers are there. Flipkart has been launched a new product. Okay. So that new product has been bought by 400 members, and rest of the 600 members they didn't buy. In the 600 members, some people says that the product is not good. I mean, it's not a kind of review, just they're looking at that, their assumption I'm talking about. Some people were looking like configuration is not good. Some people are saying that price is more. Then what Flipkart will do, they'll reduce the price 200, 300, 500. Then some people will bought. Whoever has a price concern, they'll buy. The rest of the guys, they will not buy because of the configuration, because of the build quality. They might have come across the videos, they might have come across the reviews, right? Then what the Flipkart will do, they will take this feedback. Ideally, it's kind of feedback. Then they will approach the manufacturer. They'll say that these many customers are there. I have a 50,000 customers. I have 25,000 customers. Or I have 1 lakh customers who are looking for these kind of mobile. They should have this configuration. They should have this is the build quality. They are looking for in this price range. Then your manufacturer, will manufacture product exclusively for the Flipkart. Exclusively for the Flipkart. Understand, guys?
Yes, yes.
That's how the exclusively came into picture. That is more important. That is our important. That is a value. Value is more important.
Ravi,
Go ahead.
only the product is designed for only Flipkart guys and Amazon guys also.
Sorry.
See, because Flipkart guys went to manufacturing department,
Hmm.
and they are filling all the requirements for the client customers.
Hmm.
So the product, the manufacturing guys are designed that is only for Flipkart also. They will give the same product to Amazon.
They'll not give the same product. It's exclusive for. See, if you see Xiaomi or Redmi, MI, initially
Okay.
this will be there only with the Flipkart.
Okay.
You cannot get the same mobile anywhere. But later what happened?
Mm-hmm.
Once the sale is over, once the contract is over, let's say Flipkart says that
Mm-hmm.
I want the 50,000 mobiles.
Okay.
So once the 50,000 mobiles are done, that mobile, if they want, they can sell out with other vendors.
Mm-hmm.
Initially it is with only Flipkart.
Okay. Good. Good. Yeah, agree.
Okay. And I'll tell a small story to tell about the value because it's very interesting. One of our king from India, okay, the king went to UK for sightseeing or something, some business purpose maybe. And the king visited to the Royal Rossi. It's a very big brand those days. The Royal Rossi brand, the car brand. It's like a BMW,
Yeah.
Audi,
Yeah.
or a
Yeah.
Porsche.
Yeah. Right.
So he visited that brand brand showroom, and by looking at him, the salesman didn't respect him because he is a king, right? But they don't know he's a king. But always this king's attitude, or kings or leaders or politicians' attitude is that whenever they go, they expect the respect, right? That is
Yes.
why they will do all this hangama. Before he is coming, he will send some people, say that I am coming, make some scene over there. That is why before he is going, some people will be the camp. Some people will go and they will start shouting and all those things, right?
Right.
So wherever they go, they are expecting. So the king is not get treated properly in the showroom. Then he felt bad. He went back to the showroom, went back to the hotel. Then he called his PA. After calling his PA, he said that just make a call to the showroom, order, place an order for all the cars in the showroom. How many cars are there in the showroom? You just place a call. You just place order for all the cars, including delivery charges. Then his PA, what he did, he ordered all the cars. He bought all the cars. Then very next day, the showroom guys are expecting to see who bought all the cars. The showroom guys, the salesperson is expecting. I mean, he wants to see who bought all the cars. Then the king went, and okay, the salesman felt sorry himself, but he didn't say anything to the king. He felt sorry himself, and he just hand over the documents and blah blah blah, all those things. Then he took this cars to India. They came to India. Those are very high brand. Those cars are very high brand. The only richest persons will use them, not even rich persons. Richest persons will use those cars. Then what the king is did, he brought all the 6 cars and he used those cars for collecting the garbage. Like our BM, what is that? BMC, the vans will come, right? The garbage vans, municipal vans to collect the garbage from every home to clean the roads. He started using those cars for that purpose. Then the news went viral because those are very high brand cars, but he's using for very cheapest purpose. Then everyone trying to look at why. Then it went to whole wide. I mean, everyone started looking at that. Why this guy is using like this? Then because of that, the Rolls Royce sales gone down. See, let's say you bought a good mobile and you're using for something else purpose, or you have taken a very good brand laptop, but you're using for something else purpose. When your friend knows it, or when your friends saw that, they will not go for the same kind of brand, right? Same kind of car or same kind of whatever the product. So then because of that, everyone is looking at that problem. I mean, maybe they thought that these costs are not worth enough to buy. So their sales gone down, their shares gone down. Then they started analyzing why it happened. Then they found that in India, one of the king using their cars for the cheapest purpose. Then he came to know the story, the MD of the Royal Society. I think they visited to India. They sent a letter to the king saying that we are really apologize for that. Whatever has happened to you at my showroom. So we really apologize, but don't use my cars for collecting garbage or cleaning the roads. And compensating, we will give a new brand 6 more cars. We will give 6 more cars for the compensating whatever we have done for you. Then the king accepted the apologies. Then he stopped using for the collecting garbage and all. Then the story happened. So then the Royals were see the shares gone up and they started doing that. So the value, the feedback is that much important. So if they didn't analyze it, if they didn't get a value, they could have not go up back and realize, they could have not go up and up their sales, right? So the value is more important. So after processing a huge amount of data, the variety of the data, veracity of the data, variable of the data, if you didn't get any value, It is no use, right? So if you're processing the data, that should be useful for increased business. Clear, Harsha, Anil?
Yeah, yeah.
Yeah, yeah.
Okay. Now look at how we'll solve the problem. Now we have seen what is the problem. We have seen who is causing the problem. Now we are going to see. Now we are going to see how we will solve the problem. Okay?
Yeah, okay.
How we will solve the problem? Guys, if you are getting late to your office, you can just let me know. It's already 6:45. So if you are getting late, you can just let me know. I can stop here. Or I'll just explain the high level. Then tomorrow we'll continue.
Sure.
Okay?
Okay, fine, Anand.
Yeah. So how we'll solve this problem? The six whatever we have in the limitations, we'll solve using Hadoop. It actually should not pronounce it Hadoop. Should say H-A-D O-O-P. We should say like H-A-D-O-O-P. That is the pronunciation we have to do. It should not be a Hadoop. It's like your SAP. It's not a SAP, right? It is a SAP. Same way, it should not be pronounced as a Hadoop. It has to be pronounced as a H-A-D-O-O-P. Okay, but it has been become usual to everyone. Everyone start using the pronouncing Hadoop. Yeah. Okay. So to solve the problem, we will go with the HADOP Hadoop. Okay. The Hadoop is a open source a Java framework. Hadoop is a open source Java framework which is designed and developed for store huge amount of the data, manage huge amount of the data, and process it efficiently. What is the purpose of the Hadoop? The purpose of the Hadoop is a what is the definition of the Hadoop? Hadoop is an open source Java framework which is designed and developed for storing, managing, and processing efficiently, storing and processing huge amount of the data efficiently. Store and process and manage efficiently. And it has been designed and developed by duck cutting, D-U-G-T-T-U cutting, C-U-T-T-I-N-G, duck cutting in 2006, exactly 10 years before. 10 years before. Okay, then how it will solve? So how to come up with the two beautiful tools or components, I can say. One is called HDFS, other one is called MapReduce. One is called HDFS, other one is called MapReduce. What is a HDFS? HDFS is Hadoop distributed file system. HDFS means Hadoop distributed file system. MapReduce is map and reduce. Map and reduce. Okay, we'll talk about.
What,
Go ahead.
yeah, right. If you are in Java developer,
Uh-huh.
which are the things mostly we are going to focus?
We are mainly going to
Yeah.
focus on MapReduce,
Okay.
and there is one more tool called Hive. One more tool called Hive.
Okay.
So that is not actually
Right.
Java. That's not actually we are going to write a Java code. We are going to write a
Hmm.
SQL kind of code. It's called
Mhm.
HSQL.
Mhm.
Okay, and there are something called UDFs, user defined functions, like our normal functions in Java. Okay, in Hive we'll use some UDFs that will write in Java only, but we'll see very detail about these tools later point of time. First, we'll be concentrating Hive, which is meant for the storing. That's about I would say. HDFS is meant for the store a huge amount of the data. Your HDFS says that how to store a huge amount of the data. Your MapReduce says that how to process a huge amount of the data. For the processing, we'll go with the MapReduce. For the storing, we'll go with the HDFS. Clear on it? And you will see, I'll answer the question in a very better way when the tool comes. Okay? Now try to understand what is HDFS. Okay? HDFS is Hadoop distributed file system, which is meant for storing large amount of the data efficiently. That is very much important. HDFS is meant for storing a large amount of the data efficiently. The MapReduce is meant for processing the large amount of the data efficiently. Okay. Now we are going to look at what is a HDFS. We are going to look at what is a HDFS. HDFS is Hadoop distributed file system. What is it? It is a full form of HDFS is Hadoop distributed file system. Okay. Do you guys know any distributed file systems? Existing distributed file system?
No.
Your network file system NFS. NFS.
Okay.
That is your network file system, or your DFS, distributed file system. These are all existing file systems. We'll talk about them tomorrow actually. It's already getting late. So what is HDFS? I'll just give an idea. Tomorrow again we'll start from the HDFS only. Okay.
Sure.
So before that, you should know what is a local file system. Okay, let me put in this way. HDFS is a virtual layer on top of local file system. It is a virtual layer on top of local file system. Why I'm telling it's low? Why I'm telling it is a HDFS is a virtual layer on top of it? HDFS is a virtual layer on top of your local file system.
Virtual layer in the sense this is a logical layer, right?
Yes, it's a logical layer which will not be visible. Okay.
Okay.
So before that, what is local file system? What do you guys know about the local file system? What do you guys know about the local file system? I mean, I just want to try to understand this. It's not something like, I mean, how much you have, what is your understanding about this? I just want to know that, nothing else. What is your local file system?
If you come to our local machine like laptop or desktop, we are storing the files in the folders, in the folder structures, right?
Exactly. Local file system is very much local to your operating system, right? That is managed by your operating system. Your operating system decides how to store the data. Your operating system decides how to process the data, right? How to read and write the data, which will be decided by your operating system. In the local file system, when you store the data, let's say I'm storing the data in the C drive, movies, and Telugu movies I'm keeping here. Okay. When you store this data, the local file system, the data will store in such the form of blocks. Form of blocks. What is the block size?
4 KB.
4 KB. But who decided it has to be only 4 KB? Who decided it? It is decided by your operating system.
The file size.
No, not the file size. That has been decided by your operating system.
Yeah, that operation system will come to know based on the size only, right?
Correct. Correct only, but whatever the data you store in the HDF or whatever the data you're storing in the local file system, the data will go in the form of 4 KB. Let's assume that you got only 1 KB. But even for 1 KB also it will take the 4 KB, but it will occupy only 1 KB space. But the rest of the space will be free.
Yeah. You segregate partition. partitioning the
break.
RAM, right?
Not RAM, not RAM. It's a local file system, it's a hard disk.
Oh yeah, hard disk.
So when you store 1 GB data, okay, 1 GB data,
Other
what, no, what will happen? This 1 GB data will be stored in the local file system. I'm talking about local file system, not to come to the HDFS.
okay.
In this local file
Okay.
system, the whole data will be break into 4 KB pieces.
Yeah.
Okay, so that each one 4K will store 1K, one 4K will store here, one 4K will store here. Like this, it is start storing. So who decided it has to be 4 KB only? Why can't it be 10 KB? Why can't it be 20 KB, 100 KB? That is decided by our operating system. Because
Yeah.
while designing your operating system, we'll say that you store the data in the form of 4 KBs only. You write the data in the form of 4 KBs. You read the data in the form of 4 KBs. That's why we call it as a local file system. It is very much local to your operating system. Your operating system will have a more control on your file system, right? But when it comes to HDFS, it's a virtual layer on top of a local file system. It means that it's not visible. Visible in the sense nothing is visible. Even your local file system also not visible, but it really not exist. But looks like it exists. But
Both are virtual only, right?
no, local file system is not actually virtual. It will be on a hard disk.
Okay.
Both are it's virtual in the sense both are like not visible only. But in the local file system, the data will go in the form of 4 KBs. But
Okay.
when it comes to HDFS, I'll decide my block size. It can be 64 MB, or it can be 32 MB, it can be 1 GB, it can be 512, it can be 128. I'll decide it here. I have
Manually.
manually. I have more control on
Okay.
this. Developer has a more control
Okay.
on it. But when the
Mm-hmm.
local file system will not be having more control. I'll say that the 64 MB at a time you read 64 MB, at a time you store 64 MB. I can say that. And one more thing, in the local file system we have stored one movie. Will it be duplicated? Will the data will be duplicated?
Yes.
No. Where it will be duplicated? You have to say duplication. In the C drive one place or D drive or one folder, different folders you have to save, right?
Yeah. Yeah.
It will not take automatically, right?
Yes.
In HDFS, when you store the data, by default automatically it store 3 copies. If you say 1 GB data, it will store 3 GB data. 1 GB, 1 GB, 1 GB. 3 different places to store. It's a distributed file system. It's a distributed file system. Let's assume that. What is a distributed file system? First of all, we need to understand what is a distributed file system. We'll try to look at the tomorrow. Okay. When you store one data, these are different computers. Computer 1, computer 2, computer 3, computer 4. Okay. We just try to understand this. We'll see tomorrow. I'll give you proper names for them and I'll explain properly. When you store 1 GB data, right? By default, it will store the data will be 64 blocks. That's what we have discussed, right? Are you guys able to follow? I don't think you
Can
guys are.
I
I'm following you.
Okay, you guys are following.
just listening what you are telling, right?
Okay. Fine. Now, what we have said, the data will in the HDFS, the data will be in 64 MB blocks, right? This 1 GB data, what it will do? It will break into pieces by 64 MB blocks. It means that almost 16 blocks will come, like 1024 MB by 1024 MB by even 64. When you divide it, it will come 16 blocks. So block 1 will go here. Block 1 go here because 3 copies, no? The block 1 will go here. I will tell you how it will store. And block 2 may come here. Block 2 may come here. Block 2 may come here, and so on. And block 2 may come here. Block 3 may come here. Block 3 may come here. Block 3 may come here. So it will make sure that it will not get the duplicate block. In one machine, it will make sure that always P1 will come twice, or P2 come twice, or P3 come twice or thrice. It will not come. So always make sure that it will take the one block only. Now 1 GB data. So how many how many times it's saved? 1, 2, 3. It means 3 copies. By default, 3 copies stored, right? And the HDFS, the cluster, will form with a cheaper hardware. It's called commodity hardware. Commodity hardware. It's called commodity hardware. Cheaper hardware, we'll discuss more about it. It's not costly items, it's a cheaper item. And your map, your hadoop is or HDFS is open source. And here we are storing the data in the distributed manner. The blocks we are storing here on block. What is a block? Actually, this is 1 GB is my employee data. Let's assume that. Or Amazon data. This is 1 GB data. This whole 1 GB data will be break into pieces. Break into pieces. And this is block 1, this is block 2, this is block 3, this is block 4, block 5, and so on. Right? These pieces, the data has been broken into pieces. This piece is come here. This piece is gone some other place. This piece is gone some other place, right? It means that the whole employee data has been put across the multiple machines. The whole employee data, try to understand this. This is very much important statement. The whole data is broken into pieces and stored across the cluster, across the multiple machines. In this machine one piece, 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 right? Why?
Okay.
You are telling about cluster, right?
Yeah.
The network, they are maintaining all the machines, number of machines.
Yes.
Data.
Yes, that I'll explain tomorrow, guys. Today I'm just trying to explain how we will solve the problem using this approach. The network will be there, multiple machines will be connected, all are in the network only. Okay, so my point is why I'm trying to explain the high level, because we have seen the problem and we have seen the who is causing the problem. Now we are going to see how we'll solve the problem, and in detail about the how to solve the problem in detail we'll see tomorrow. Okay, so the whole employee data has been broken into pieces, and I stored here, I stored here, I stored here, I stored here. Okay, why you have to store the data? Why can't you store whole data in one machine? Why you are storing multiple machines? Because
configurations.
Sorry.
Configurations issue.
Sorry, your voice is echoing.
Configurations issue, because if you
not no, not for the configuration issue. I'll tell you that. Let me tell you. Let me tell you a simple example. I have 10 apples in one box. I have 10 apples in one box. Then I asked one person to take all the apples. How many attempts he will do? One box, I have 10 apples, and I asked him to, the box is not it's fixed. You can say whole box I'll take at a time, but you cannot take whole box at a time. The box is fixed. Let's say it has been concreted. Like I can say it is a cement box, which is already stick to the floor. The box will not detachable. The box is attached. It's not detachable. Okay. In that box I have 10 apples. I asked one person to collect all the 10 apples. How many attempts he will do to collect the apples? How many attempts he will do to collect the apples? 10 apples are there in the box. He is trying to collect the apples 10 times. Each time he will take one apple, right?
Yeah.
And what I did, I have 10 boxes. In each box I kept the one apple. This time I tell to the 10 people, not the one person. This time I tell to the 10 people, guys, you go ahead and collect the apple from one box respectively. So then, for the high level, how many attempts? One attempt, right? It means that we are saving some time. The same way here, if I store whole data into the one machine, to process the whole data, it will take so much of time.
Yeah.
But the whole data break into pieces. You break into pieces. Then you store one piece here, one piece here, one piece here, one piece here. While processing, you process by multiple people. It means multiple machines at a time. Then we're achieving a parallel process here.
Yeah.
Let's assume that this employee data, I want to see whose salary is whose salary is whose salary is more than 10,000. Greater than 10,000. Okay. Now, when I break this employee data, some amount of data will go here. 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 Right? Let's assume that this employee data has a 40 lines, 40 rows. When I break it into pieces, 10 rows will come here. 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 Am I right? Anil, are you guys able to follow me? So my whole data has a 40 rows of 40 rows are there in the whole data. I have split it into 4 boxes. Let's assume there are only 4 blocks. Now here I have a 10 lines, and I will be having 10 lines here. I will be having 10 lines here. When I issue the command saying that select star from employee where salary greater than 10,000, right? Now that query will execute here in this 10 lines. Here also will execute 10 lines. Here also will execute 10 lines. Here also I am executing 10 lines. If you see here, what I am trying to do, wherever the data is there, I am going and executing that place. You guys observe this?
Yeah.
Wherever the data is there, I am executing that place. I am not taking the data to other place. I am not downloading the data. My logic is going towards data. My logic is going towards to the data, not other way. My data is not coming towards logic. My logic is going towards data. It means that it is a commodity hardware, it is open source, and it is data locality. And these 10 lines are processed. It's given the result of employee 101, 105, or some 120. Let's assume some 120. 3 rows it's given. These guys have the more than 10,000. This is also given some result. This also given some result, but here no one has more than 10,000 rupees. It's not given anything. So I want the final output in sorting order. Let's assume that now this whole data will be go to reducer. We'll talk about the reducer later point of time, and we'll get the final output here. Clear, guys? What does it mean? My data has been processed parallelly. My data is distributed in multiple machines. Right? Let's assume that.
Instead of searching one place, it's taking a lot of time. So that we are doing multiple processes and reduce the time and right.
Yes, it's kind of divide and conquer, Harsha. See, I have one apple. I have cut it into 10 pieces. Okay, and I ask you to. I have one apple. I ask you to eat it. I ask to eat one person. So he cannot eat whole apple at a time, right? He has to eat bite by bite. Instead of that, what I done, I cut the apple in 10 pieces, and I given to each piece to one person. I have given to 10 people.
Understand concept.
Yeah, so they can easily eat, right? The same concept here. So the whole data has been broken into pieces, and I given to 10 different machines, and each machine will process parallelly. And I understand that what you guys may ask me, each machine will do the part of the data only. Each machine will process the part of the data, not the whole data. I am okay with that, because I have at the end, I have one more guy called reducer who will collect all these parts and make it club, and who will give the one piece, who will give the final result. I'm okay with it, right? I'm
Yeah, yeah.
anyway. At the end, I need the result. How you process, I don't mind. Whether you have cut into 10 missions, you have taken one mission, you have 100 missions, I don't mind. I want the report in 5 seconds. You take how many missions you want. Whether you go with one mission, whether you go with 100 missions, I don't mind. But the end, in 5 to 10 seconds, I want the report. Understand, right?
Yeah, yeah.
Now, this is distributed. So distribution also came, and data locality also came. The time taking, very less time, right? Comparatively, time is very less. Cost, because I'm using commodity hardware, cost is less, right?
Yeah, yeah.
We overcome all the issues. The cost, yes, because I'm going with a small amount, cheaper machines, very less cost, very less cost. It's an open source, no cost. Wherever the data is there, you go and process that place. Data locality. I'm processing the data parallel, and data is distributed. Multiple machines, the data is there because the parallel is easy, distributed. Time is taking. And what is the other one? Fault tolerance, auto fault tolerance. Now I have launched the job. Here on have one block. Let me take other colors. Now I have processed. Here block one is there, and here also block one is there, and here also block one is there. Right? Three places I have block one. While processing this block, this machine is gone down. Will my job will fail? No.
No, no.
My job will not fail. Automatically, my job will move to here and my job will launch here. This also fail? Yes, my job will be launched here. This also fail? Then only my job will fail. My cluster or my Hadoop is smart enough to identify the auto fault tolerant. This is fail. Okay, anyway, I have one more copy. No, I'll go and execute there. If that is fail, anyway, not a problem. I have one more copy. No, I'll execute there. If that also fail, that's the worst case. Why I'm telling it's a worst case, I'll explain the architecture. That time you'll come to know. There is no possibility to all the blocks will crash because we're not storing in all in a single machine. We are storing different machines. Not only machine, different rack. We are going to store blocks into different rack. That is very much important. So there is no scenario. All the racks will fail. All the machines will fail. If that is the case, it's kind of disaster. It's kind of disaster or something we can accept. But in normal cases, this will not happen. Okay. Once this block is failed, my job is launched here. My job is not failed. This also failed. My job is launched here. My job is success. So automatically my job is not failing. Automatically the fault get tolerated. Automatically my fault is the auto fault tolerance I am achieving here. So my job is not failing. Instead of because of one mission is failed, my job is not failed. My job is continued. Right? Let's assume that today I have this much amount. Tomorrow my data is increased. On the fly, I can just go ahead and add the machines. On the fly, I can just go ahead and add the machines. I no need to restart also. I just need to add the machines at the end. I just need to add the machines to the cluster. That's enough. And highly scalable. It is a highly scalable on the fly. You just say you now 1 TB data is coming. Tomorrow 1 PB 1 petabytes came. You don't need to do. You add 10 more machines. That's it. On the fly. You don't need to stop your cluster also.
Ravi,
Yeah.
who did all these things, adding the computers?
See, it will ideally do by the administrator. Hadoop administrator.
Hadoop administrator, or if you come with Amazon, no? Amazon is building a lot of data. They are going to handle the data, right?
Correct. Actually, there are two type of clusters. One is the in-house cluster. Another one is the cloud cluster. Okay. In-house cluster means we will install the cluster. It means that in our home, our office. It can be any other location, but in our office. It's dedicated to only my office. cloud cluster is the hardware is maintained by hardware and everything is hardware and software is maintained by Amazon or Azure, Microsoft, or some other person, whoever it is. If it is Amazon, it's very simple. You just say, boss, I want 100 nodes today. 100 missions I want today. Tomorrow your data is grown. Boss, not 100 missions. I want 1,000 missions. Automatically scale up. Okay?
So someone has to be there to maintain all clusters of the system.
Someone means Amazon. Amazon has those many employees to manage that.
Okay. So dynamically they are going to have the machines from the cluster side.
Actually, it is not manually. Already they will be having thousands of machines. Okay, not even thousands. There will be more machines.
Already set up as done, right?
Yes, they will be having all the machines, Anil. So when you say I want this many machines, on the fly they will do.
Okay. So the backend they are going to handle it.
It's not like
Based on the data.
they will not manually add them. Okay, cluster in the sense it's not like every day they'll go and add one. Cluster in the sense already there will be so many missions. Okay, when I say I want these many missions, they will be having their own applications. They will be having their own Amazon applications. What at that will choose how many missions it want, it will allocate those many missions.
Mm-hmm.
See, when you say 10 missions today, when you said 10 missions today, tomorrow you said that I want 100 missions. So it's not like they will add all the missions. Let's just try to look at this diagram.
They will increase memory, Ravi, I think.
No.
Right?
It's not memory. They will be having a dedicated missions. They will be having dedicated missions. See, they will be having racks like this. It's not one rack. They will be having thousands of racks. Thousands of racks. Each rack will have again hundreds of missions. Each rack will contain hundreds of missions. If you guys get a chance to look at your server room, you will look at the server room. Your server rooms will be look like this. The racks will be there.
Agree.
The racks will be laid like this. So many racks will be there. It's not one or two racks. There will be so many things will be there. Today when you say 10 missions, right, they will give 3 missions from here, they will give 3 missions from here, from 4 missions from here, and again 3 missions from here. 10 missions are done. Okay, 10 missions are done. Tomorrow you said 100 missions. Then they will select from here one of the missions, which is the free, which are the available. Then they will give on the fly. So already available missions are available with them. So how they will choose, how will they will maintain and all, they will be having their own applications. When you say 100, it will choose 100. When you say 10, it will choose 10 only. They will be having their own tools for that.
Okay.
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 Yeah, fine. How they will choose and how they will do will, even I really don't know because what their internal applications. But what we are using Amazon Web Services only. What we say, today I want 5 nodes. On the fly. When I submit a job, along with my job I'll say, when I submit my MapReduce job, right, along with my job I'll say, I want 10 missions, or I want 100 missions, or I want 50 missions, along with the job. So on the fly they will take care automatically. So how they are handling, sorry?
Do we need to write the code for getting the notes?
No, we don't need to write
How many
any.
minutes will write?
No. That will be configuration. That's a simple configuration. They want one parameter.
Okay.
The Amazon need one parameter saying that how many missions you want.
Okay.
It is a number of EC2 instances. Number of EC2 instances. You just will send the number. 10 number, 20 number, 30, 40, 50, your number. That's it.
Okay.
Okay.
Good.
So you guys understand from the problem statement and who is causing, how we solve that. This is very much important.
Yeah.
So if you understand this basic, right, we can easily go ahead and continue other parts. Tomorrow we'll see the architecture, the same architecture what we have discussed here. The same architecture we'll discuss tomorrow. We'll see more detail. Before we'll see what. Yeah.
Something right.
Tell me.
It will be an overall picture as a real time because the real time thing will be very easily to understand all the things.
Yes, I'll be explaining the real time only. But we need to understand this the basic
Yeah, I
architecture.
agree. just inject the as it's a real-time payment. If you enter into the company with this basic knowledge, you can able to handle the order technology.
That's correct. What I'm trying to do here, I'm giving the basic information now. Okay.
Okay, sure. Okay,
Yeah. Once you're comfortable with this, I'll explain that.
okay, okay, sure.
What my plan is,
Okay.
whatever the 1 second guys. My plan is